Hello everyone. So your next activity is the thermochemistry Hess's law. Consider the energy diagram given below. The total enthalpy for the grouping of the compounds and their amounts are given and their energy differences are shown. Here, the overall reaction is a balance equation for the combustion of methane. The enthalpy for this combustion reaction is negative 890 kilojoule per mole. You can also see this one on the energy diagram. However, you can imagine that this reaction happens in two steps. First, the methane and the oxygen react to form carbon monoxide and water with some oxygen left over. From the enthalpy diagram, this is the enthalpy 1 of the reaction, which is equal to negative 607 kilojoule. Next, the carbon monoxide and the oxygen react to form carbon dioxide with the water already from the first step. Here, from the energy diagram, you can see that the second enthalpy of the reaction is equal to the negative 283 kilojoule. The net reaction is the same, which means that the change in enthalpy is the same. You can see that the overall enthalpy change should be the same as the sum of the two-step process. Here, the enthalpy of the reaction is equal to the sum of the two enthalpies, which is equal to negative 607 kilojoule plus negative 283 kilojoule. This will give you a sum of negative 890 kilojoule per mole. So if you look at this value and the value indicated on the energy diagram, you know that it's actually the same. So this is Hess's law in the simplest case of just two steps, giving an overall reaction. So you have to remember, class, that the Hess's law is not limited to just the sum of two reactions, but there are other reactions which pwedeng dalawa, tatlo, or more, okay? So in practice, there could be numerous steps to combine to get the overall reaction. You just need to have to keep track of the separate steps that are involved. The enthalpy change is just the final state minus the initial state. Any reaction written in the opposite order will have the same enthalpy with the opposite sign. So enthalpy is a state function. It means that it only what only matters for an enthalpy, for a state function, is the initial and the final state, okay? So here you can see the chemical reaction or the combustion of methane. Okay, so it has a negative 890 kilojoule per mole heat of reaction. Now, if you're going to reverse the reaction, making carbon dioxide and water as your reactant and your methane and oxygen as your products, the heat of reaction will also reverse. So from a negative value, it will now become a positive value of 890 kilojoule per mole. Also, if you change the coefficients in the balance equation, say for example, you multiply the coefficient by 2, then the enthalpy will change accordingly. So here, if you increase the number of moles of methane from 1 to 2, all the coefficients will also be multiplied by 2, including the heat of the reaction. So from the original heat of reaction of negative 890 kilojoule per mole, it will now become negative 1,780 kilojoule per mole. In your experiment, it will allow you to explore the quantitative aspects of the constant pressure calorimetry, and you are going to check the validity of the Hess's law. So in the video, you will actually see that they have used a coffee cup calorimeter, okay, to measure the heat released by the three related reactions. Because the two of the reactions sum up to give the third reaction, you can use the set of measurements to check the Hess's law of heat of summation. Okay, so there are three reactions that will be happening. So in the first reaction, there is a dissolution process. So solid sodium hydroxide is dissolved in water. So what is the heat of the reaction? Okay, and now on the second reaction, the same amount of solid sodium hydroxide reacts with an aqueous hydrochloric acid to form water and aqueous sodium chloride. Okay? So on the second reaction, what is your heat of reaction? And lastly, in the third reaction, aqueous solution of sodium hydroxide and hydrochloric acid react to form water and aqueous sodium chloride. Now, what would be the heat of reaction for this last equation? So you have to assume that the heat losses are not significantly different from one trial to the next. So ibig sabihin, class, you are going to assume also that the specific heat of water is the same as the specific heat of the different solutions used in the experiment. Okay, so please refer to the video. Okay, so there are two videos for this experiment. Kindly obtain your data on the second video kasi mas klaro siya doon. And then, please show all your calculations for all the computations needed in your report sheet. Okay? And then for the computation of the percent difference, you are going to use the values obtained on the letter C and D of your question number 1. Okay? And then you have to multiply it by 100%. So from that, you can calculate the percent difference. Okay? So Hess's law is a state function. So it means that it is path independent. So you can see here that there are several ways to reach the finish line. So what only matters for a state function is the initial and the final state. Okay, so the net result is always the same, whether it was taken too long or shortcut. Okay, so for the first example of the Hess's law, you have to determine the heat of reaction for the reaction. Here, this is a combustion of ammonia. Okay, so this is your main reaction. Okay, now you are given the following sets of the reactions. Here, the three reactions must be algebraically manipulated to sum up to the desired reaction, and the enthalpy values must be treated accordingly. So yung technique, class, to calculate for the Hess's law is that you always need to look at your main reaction. Okay, so ito yung main reaction nyo. Now first, you have to identify if which among the three reactions saan matatagpuan si ammonia. Okay? Okay, yes, you're correct. So nasa second reaction siya. But if you look at the two reactions, okay, so in your main equation, you have ammonia as reactant, and in your second equation, you have ammonia as product. So what you're going to do is, you are going to reverse this second reaction, okay? So, i-reverse nyo yan. Then, after that one, if you look at the coefficient of ammonia and the coefficient of ammonia in your reverse reaction, there is a difference. So, what you're going to do is you have to find a coefficient that you will multiply to the second equation so that it will now have a 4 moles of ammonia instead of 2. Okay, so what you're going to do, you are going to multiply the second equation by 2. Okay, so ito times 2 nyo yung second equation. Okay, and then after which, you also need to multiply the heat of the reaction na times 2. Okay, after reversing and multiplying the second equation, what you are going to do next is, you have to look at the products. Okay, so in the products, you have nitrogen oxide, okay, and water. Now, if you look at the three equations, saan mo makikita si nitrogen oxide? Yes, it is found on the first equation, okay? And both equations, nitrogen oxide is found on the product side. So there is no need to reverse the reaction. However, in your main equation, you have 4 moles of nitrogen oxide, okay? And you only have 2 moles of NO in your first equation. So what you are going to do is you have to multiply your first equation by 2. Okay, so this is now what happens if you are going to multiply the first equation by 2. So you have 2N2 plus 2O2 will give you 4NO. Of course, you also need to multiply the heat of the reaction by 2. So from 180.6, it will now become 361.2 kilojoule. Okay, now, next step is to look at the number of moles of water. So from your third reaction, you know that there is only 2 moles of water. And in your main reaction, you have 6 moles of water. So what you are going to do is you are going to multiply the third reaction by 3. Okay, so it will now give you 6 moles of hydrogen, 3 moles of oxygen, and 6 moles of water. Of course, you also need to multiply the heat of the reaction by 3. So it will now become negative 1,451.1 kilojoule. The next step is to cancel out the common reactants and products, okay? So, in your first reaction, you can actually cancel out the 2 and 2 from the second reaction, okay? And then you also cancel out the hydrogen from the first reaction to the third reaction, okay? Leaving you with 4 moles of ammonia, 5 moles of oxygen, with the products of 4 moles of NO and 6 moles of water, okay? And also, you need to add all the heat of the reaction. Okay? So, i-add nyo lang yung lahat yan, class, and it will give you a negative 906.3 kilojoule. Okay? So, if you look at your goal equation and your final equation, they are both similar. So, tama yung steps na ginawa nyo na reversing the equation and multiplying it with different coefficients. Now, the question is this reaction endothermic or exothermic? Yes, this is an exothermic reaction because if you look at the enthalpy of the reaction, it has a negative sign. So, a negative delta H would mean that the reaction is exothermic. Okay? And also, this one is a combustion reaction. So most of the combustion reactions are all exothermic processes. Okay, let's have another example. So here, you have to determine the heat of reaction for the reaction of ethene, okay, plus H2 will give you ethane. Okay, so using this 3 equation, what are you going to do? Okay, so if you need to consult your neighbor, then do so. Okay, or if you need to consult Google, you may do so. Okay, so yan. If you look at the 3 equations and the main equations, there is actually not much to do. Okay, kasi if you look at the reactant, here we have the ethene. Among the 3 reactions, you can also see the ethene on the reactant side, okay? So, hindi na kailangan i-reverse si first reaction. Now, if you look at your product, so ethane here is actually on the product side. But on your second reaction, si ethane is found on the reactant side. So, what you are going to do is, you're going to reverse the second reaction, okay? Okay. Now, if you look at the hydrogen is found on the reactant side, and your third equation, nasa reactant side din si hydrogen. So, therefore, there is no need to reverse the third equation as well. Now, after reversing, you have to add all the terms and cancel out the common terms. Okay, so you have to remember na pwede lamang kayo mag-cancel if the compound is found on the reactant side and the other compound is found on the product side. Okay? Hindi kayo pwedeng mag-cancel out pag parehas silang nasa reactant or parehas silang nasa product side. So, what you will do is you will add those pag nangyari yon. Okay? So, here in the three reactions, you can actually see that the oxygen, the carbon dioxide, and the hydrogen are all canceled out. So what is left here is the reaction with a negative 137 kilojoule heat of reaction. Okay, so yung goal equation and your final equation here are both similar with you getting a negative 137 kilojoule na heat of reaction. Okay, so that would be all for the Hess's law computation. So I hope you're able to learn on how to compute for the Hess's law or for the heat of the reaction using the Hess's law. Okay, so as a summary, enthalpy is a state function and is path independent. Okay, so this is another example. This one is an energy or an enthalpy diagram of the conversion of graphite. Okay, so this one is reaction of the graphite. Okay, the composition niya. Okay, so another information is that meron din tayong mga thermodynamic quantities of different substances. Ibig sabihin, these are the heat of formation of the different substances. Makikita nyo to sa likod ng textbook nyo. Okay, so you can actually see the delta H, F, which is the heat of formation, delta G of formation, and then you have the entropy. Okay, so you can actually use these values in calculating for the different heats of reaction. So this is your report sheet for your next activity. So here, you have to obtain your data from the second na video. So the link is for the first video, but you are going to get your data on the second video. Okay, so you need to fill up all the needed information, and then you have to show all your calculations. Okay, so for the net ionic equations, you are going to include the enthalpy of the reaction for the first equation. Okay, first reaction rather. Okay, so this is your first reaction, and then for the second reaction, and then for your final reaction. Okay, so for the percent difference class, yung gagamitin nyo dito is that you are going to use the values obtained from letter C and letter D. Okay? So dito, you will not have any value. So NA dyan, you only have a percent difference for the reaction 3. For the reaction 3, you are going to use this equation, percent difference is equal to D minus C divided by the value of D times 100%. Okay? So this is how you are going to calculate for the percent difference of your third reaction. Okay? Now, after completing everything, you have to answer the second question. Do your results agree with the Hess law to within the 1%, 5%, or 10%? Ibig sabihin, pagpasok siya within the 3, it would mean that your computation is or follows the Hess's law. But if not, if it doesn't fall on the three given percentages, then you have to suggest any possible reason bakit kaya siya may discrepancy. Okay? So, yun. Kailangan i-calculate nyo kung saan siya pasok dyan or kung hindi ba siya pasok, ano yung maaring dahilan. Okay? So, I think that would be all for your activity number 7. If you have any questions, you can ask me through our group chat in the messenger. Okay, so that would be all. Thank you very much.